Have you ever been puzzled by a piece of code that just won't compile? It's frustrating, right? If that's you, then you're in the right place. Today, we're diving into the complexities of overload resolution in C++ and how to resolve issues with multiply inherited operators. I know how annoying it is when your code fails to compile, especially when you think you've done everything right. Trust me, you're not alone. This is a common issue many developers face when dealing with inheritance and operator overloading. Here's the specific situation we're looking at. One user recently asked about a C++ code snippet that fails to compile due to ambiguous overload resolution with the print function. They were confused about why using operator parentheses seems to yield different results across compilers. Sound familiar? If so, let's dig into this together and find a solution. So what could be causing this confusion? In C++, when you have multiple inheritance, the compiler needs to resolve which function to call. This can lead to ambiguity, especially when the same function name exists in different base classes. We'll break it down step by step so you can understand what's going on. And don't go anywhere. I've got a surprising twist at the end that will clarify why different compilers behave differently in these situations. To address the user's question about overload resolution with the operator function, we first need to understand how C++ handles operator overloading in the context of multiple inheritance. In the first example, the user has two base classes, each with an operator function. When the user tries to call the operator with different types, the compiler needs to resolve which operator to use. The user noted that while GCC fails to compile due to ambiguity, Clang and MSVC compile successfully. This indicates a difference in how these compilers interpret the C++ standard regarding operator overloading. In the second example, the user uses lambda expressions to define the operator functions. The behavior changes again, highlighting the nuances of how different compilers handle overload resolution. To summarize, the user should consider the specific rules of overload resolution in C++ and how different compilers may interpret these rules. This can lead to varying results, especially in complex inheritance scenarios. Did you know? The rules of C++ can sometimes feel like a game of chess, strategic and full of surprises. Just when you think you have a winning move, the rules change. Now, let's look at the answers provided by other users. The user explains that name lookup in base classes only occurs if the derived class doesn't directly contain the name. If both base classes declare the same name and the derived class doesn't use a using declaration, the lookup fails due to ambiguity. They conclude that in both cases, GCC is correct, as the difference between print and operator is merely the name being looked up. The user also notes that the same reasoning applies to lambdas, which create unnamed class types with overloaded operator. They assert that the code should be ill-formed for the same reasons, pointing out a specific GCC bug related to this issue. Now let's see a response from a different user. The user clarifies that the initial analysis of the code is incorrect because there is no overload resolution happening. Instead, name lookup occurs first, and if the name isn't found in the derived class, it checks the base classes. If the name is found in multiple base classes, it results in ambiguity. They also point out that calling f1123 does not always mean f.operator1223. The definition in C++ 14 specifies that the call is interpreted as f.operator only if it exists and is the best match. This leads to inconsistencies across compilers, as the standard's wording can be ambiguous. Finally, the user questions why the standard doesn't simply state that f123 means f.operator123, suggesting that understanding the intent behind the wording could clarify which compiler behavior aligns with that intent. Here's the pro tip I promised. Always be explicit with your using directives when dealing with multiple inheritance. This can save you from a lot of headaches and confusion down the line. And there you have it. Understanding overload resolution in C++ can be tricky, but with these tips, you should be able to navigate it more easily. If you found this helpful, hit the subscribe button for more coding insights. And don't miss our next video where we tackle another common coding conundrum.